welcome back, learners. This is going to be to form the third part of our mole concept question. And in this question, you're told urea is prepared by a reaction between ammonia and carbon dioxide. Then you have ammonia and carbon dioxide reacting to form urea and water. You're told in one process, 340 kg of ammonia were reacted with excess carbon dioxide gas. Calculate the number of moles of urea formed. Hydrogen is equals to 1, carbon is equals to 12, nitrogen is equals to 14, oxygen is equals to 16. When you make this question, this is an industrial process. You're most likely to experience a very huge number of moles. So you don't need to get surprised when you get 10,000 moles, 20,000 moles, 30,000 moles. This is an industrial process. And that means the number of moles you're most likely to get here are very high. Now, you look at the information that we've been provided with first. Now, if you're watching our channel for the first time, kindly take time, subscribe, like and share. You can also share the link with your friends and colleagues from other schools. Now, we are saying in one process, 340 kg of ammonia was reacted with carbon dioxide. Now, that is the first thing that you're going to note that we've been provided with. We're provided with mass, the mass of ammonia. The mass of ammonia. Okay? And for this case, our mass for ammonia is equal to 340 kg. That is very important. Now, because we are provided with mass of ammonia, the next thing we are going to get is RFM of ammonia. RFM of ammonia. So if we get the RFM of ammonia, we are going to get the RFM. Now, how do you get the RFM of ammonia? This is another question that you must be asking yourself. How do I get the RFM of ammonia? Ammonia is NH3. Leave alone these two. This 2 is only used to balance this equation. So you don't include it when you're getting the RFM. So RFM will be nitrogen, which is equals to 14, plus the hydrogens are 3, and hydrogen is 1. So that is just plus 3. So from there, you're going to get that your RFM is going to be 17. Now, once you get that your RFM is 17, it is also very important that because now we have the mass and we have the RFM, that means we can get the moles. Because moles is usually equal to mass. Moles is usually equal to mass over RFM. Mass over RFM. So that means we can get the moles now. So our moles is going to be equal to our mass. Our mass is 340 kg. But remember, this 340 kg, you cannot work with it in kg. So you have to convert it into grams. And how do you convert it into grams? You convert it into gram by multiplying it by 1,000. So when you multiply it by 1,000, you're going to get the mass in gram as 340,000 grams. That is now your mass in grams. Now, once you get the mass in grams, now you can work it out with this 17. So now our moles is going to be our mass, which is 340,000 grams over 40,000 grams over our RFM, which is equal to 17. Our RFM is equals to 17. So we can now get the number of moles from there. So now our number of moles, if you calculate here very well, you're going to get the number of moles. And remember, these are moles of ammonia. The number of moles of ammonia is going to be equal to 20,000 moles. So you don't need to get surprised about this huge number of moles. Remember, I told you this is an industrial process. So you're likely to get a very huge number of moles. Now, these are moles of ammonia. But remember, the question asked you the number of moles of urea. So how do you get the number of moles of ammonia? You look at the mole ratio of ammonia to urea. I want you to look at the mole ratio of ammonia mole ratio of ammonia, the mole ratio of ammonia to the mole ratio of urea, the mole ratio of urea. I want to show you, you're going to see that the mole ratio of urea. You look at ammonia, here is 2. You look at the value before ammonia and the value before urea. Before ammonia is 2, before urea there is nothing. So that means the mole ratio of ammonia to urea is mole ratio 2 to 1. Ratio 2 to ratio 1. That means, and already we have the moles of ammonia as 20,000. So that means the ammonia, which is 2, the ammonia, which is 2, has already produced these moles, which is 20,000. The 2, this 2, has already produced 20,000 moles. Has already produced 20,000 moles. So you say, if 2 has produced 20,000 moles, what about the 1 for urea? So now you now be able to get the moles of urea. So you say, what about 1? So what about 1? You simply cross multiply at this point. Just cross multiply, and then you will now be able to get the moles of urea. You'll be able to get the moles of urea. The moles of urea are now going to be equal to 10,000 moles. 10,000 moles. So those are now the moles of urea. And you can see this question is very interesting, and that's why I told you, before you solve this question, you must ensure that you have used all these values that you are provided with here. So now we have our number of moles of urea as 20,000 moles. This is very important, learners. And if you are watching this channel for the first time, take time, subscribe, like and share. I'm also doing another subsequent video on moles so that you learn more of this. Thank you.